Okay, so good afternoon, everybody. Last time I started to explain Boolean logic operation. I told you what I mean by this. It means bitwise or bit by bit logic operation. Okay, logic operations are like AND or XOR. Okay, you should know them from the previous classes. And we use this symbol for AND, plus for OR, and this symbol for XOR. And here, when you do any of this operation, we actually do it bit by bit. So we do it byte to byte, but when we do it byte to byte, we do it bit by bit. You got what I'm saying? So as I'm going to teach later, when you do AND, you actually AND byte to byte, right? And to do that, you have to do AND operation bit by bit. Okay. Anyway, I'm going to elaborate. So here I'm explaining how AND works. You already know before, AND should give you one only in one case, if all the inputs are ones, otherwise give you zero, right? So here I can say it in a different way, or a little bit different way, okay? So what I'm saying here, if one input is zero, okay, regardless x, okay, x means anything, 0, 1, okay? So here, if one input is zero, the output is zero. It doesn't matter what is the value of this input. It doesn't matter. One input zero, the output is zero. Okay. And if one input is one, the output here should equal this input, right? So what this can tell us, it can tell me if you wanna put zero in a certain bit, okay? So I can put here zero, and if you don't want to change some bits, you can put one. What this means, I told you before. I told you last time that we're going to use this operation to do what we call bit manipulation. What this means, it means I have a byte and another byte. So I have 2 bytes, okay? And then, sorry, I have 1 byte, okay? And I wanna clear some bits and don't change the other bits. You got what I'm saying? So I have a byte and I wanna clear or set or flip. So I wanna manipulate some bits and don't change the other bits, okay? And I have to do the operation on a byte because we don't have an instruction to do operation on bits, or we may not have too many of them, okay? So I want to work on a byte, and after I do the operation, some bits I want to set, clear, or flip. So I want to manipulate some bits, and I don't want to change the other bits, okay? Number one, how this can be useful? It is very useful. We are going to use it all the time. I give you one example here, guys. If this is a microcontroller, okay, and we connect a number of LEDs to port, one of the ports, okay? So actually, what you have to do is, you have, here we have a port. This port is a byte. You got what I'm saying? So now I have a byte. Now I want to turn this LED off. So I want to manipulate only 1 bit in the byte, right? And I don't want to change the other, it changes the other ones, right? This is how we will use it, okay? Because as you will see in next chapter, when you have a byte, every bit, the value of every bit is going to be reflected, on an external pin, okay? So every external pin should have 1 bit in a byte. All what you have to do, and that's what we are going to see in chapter 3. If you put 0 in this byte, you put 0 volt here. If you put logic 1 in this byte, you put here 5 volt to turn the LED on or turn off, as you will see in next chapter. But I'm explaining now why sometimes you have a byte and I want to change some bits and I don't want to change the other bits, okay? Doing byte operation. So I want to do operation on a byte, okay? So that after I finish the operation, some bits are manipulated, the other bits should be not changed, okay? We will do it all the time, very important, as I told you, okay? So now, look how AND works and to figure out how AND can help us in this case. Look how it works. And it's telling me if you put 0, so I'm gonna get 0. If you put 1, no change. Okay, so that means and can be used if you have a byte. I want to clear some bits and I don't want to change the other bits. To do that, the bits you want to clear, you have to put 0 under these bits. The bits you don't want to change, you have to put 1 under these bits. This is how it works. If I put 0, I get 0. If I put 1, I'm going to get the same bit again. Is that clear, guys? I'm going to elaborate later, but this is the main idea. The main idea, I have a byte. If you want to clear 1 bit or more, so this bit, I'm going to put 0 in the position of this bit. I'm going to put 1 everywhere because 1 is not going to change. And then I'm going to do AND operation. So the result will be the same initial byte, but after clearing some bits. Okay, guys? I give you here again examples, the same example here. As you will see in next chapter, you have here 8 pins, external pins. Every pin is connected to one bit in a byte in a port. So in programming, you have to read this byte. After you read this byte, now if I want to put 0 volt here to turn the LED off, all what you have to do, you have to put in the corresponding, because every pin should have a corresponding bit. So I have to put 0 here in the corresponding bit. Okay, guys? Same thing. If I want to put 5 volt here to turn it on, I have a byte. I have to put in number 1. Okay, and cannot be used to put 1 to set, and can only use if you want to clear bits. Is that okay, guys? Okay. What about OR? Again, I'm going to explain how OR works, and you should figure out how OR can be used to manipulate bits. Okay, let's see how it works, guys. This is how OR works. If one input is 1, okay, so regardless what value here, the output is 1. Okay, this is how OR works. It is enough to have one input here with 1 to get 1, right? So regardless whatever here, it doesn't matter. As long as this is 1, the output is 1 right away. Now, if one input is 0, I'm gonna get the same value of the other input. Okay, are you sure? Okay, let me check. If I put here 0 or 0, I'm gonna get 0. So I put 0, get 0, right? Let's put 1. 0 and 1, I'm gonna get 1. So whatever I put here, I'm gonna get it here. Is that okay, guys? So now let's figure out, based on based on my explanation how OR works. Let's figure out how OR can be used to manipulate some bits. Okay, it should be very easy. Look here, guys. If you want to set some bits, I have to put 1, because regardless whatever there, I'm gonna put 1 in the position of this bit. Okay, the bits I don't want to change, I'm gonna put 0 there. You got what I'm saying, guys? So very easy, right? So for example, if you look here in this example, this pin is associated with this bit. So now I want to turn the LED on. All what I have to do, I have to put 1 here. So how can you put 1 here? And again, don't you change the other ones, because the other ones are connected to something else. So I don't want to change the other ones. Okay. So all what I'm gonna do, I have a byte here, guys. I'm gonna do OR operation, or with 1 here and zeros everywhere, right? Because when you put 1 here, the result should be 1, right? But when you put 0, no change. I'm not gonna change this one. Is that clear, guys? Any question? Please don't be shy. I am here to help you. I am here to if you learn this course and you love it, I will be happy. So don't be shy. If anything is not clear, just unmute and talk to me. I know online teaching is not perfect, but again, because of this pandemic, we don't have option. But all what can we do? Yes, we are unfortunate to have online teaching, but still we can do our best to do good teaching. You got what I'm saying? So I don't see you But again, if you have, you can unmute the mic and talk to me. Okay, if you at any time, you are very welcome to do that. I'm here to help you. Okay, guys. Anyway, now let's again look how XOR works. Okay, and then based on that, we can see how XOR can help us in bit manipulation. Okay, so let's see how XOR works. If you put here 0 XOR X, you are gonna get the same value X. Okay, so for example, 0 0, you are gonna get 0. 0 1, you are gonna get 1. Okay, and if you put 1 here and this is X, you are gonna get the opposite flip of or the complement of X. So 1 1, I'm gonna get 0. 1 0, I'm gonna get 1. Okay, so this is, again, I didn't invent this. This is how XOR works. This is a definition, right? So this is the definition for XOR. Now, based on this definition, let's think about it. How XOR can help us to manipulate some bits. Let's see. If I put 0, no change. So 0 is gonna make no change. 1 is gonna make flip. You got what I'm saying? So if I wanna flip this bit, flip. So all what I have to do, I have to do XOR operation. I am gonna put 1 here and 0 everywhere, because 0, I'm not gonna change these ones, and also I wanna only manipulate this bit. So I'm gonna put 1 here. Okay, very interesting. So when you flip a bit, that's what we're gonna do in the next chapter. If you wanna make a flashing LED, flashing means you turn on for some time, off, on, off, on, off, flashing. To do a flashing LED, all what can we do? For example, every 1 second, I'm gonna flip this bit every 1 second. Okay, using this idea. So let me tell you the conclusion here, guys. The conclusion: we have 3 instructions. Okay, logic instruction and bitwise logic instruction and or XOR. I explained how they work. Okay. Also, I explained how can we use them for bit manipulation. In 1 sentence, just I want to make it very easy. In 1 sentence, very simple. If you want to clear some bits, your friend is and is going to help you, right? If you want to set some bits, OR is going to help you. If you want to flip some bits, XOR should help you, right? Okay. Also, if you want, very clear. So if I tell you in a question, clear, it means use AND. Set, use OR. Flip, use XOR. But now, how you are going to use them? Very easy. The way you have to use them is, as you see here, guys, the bits you want to clear, you have to put 0 in the position of these bits to clear them. The bits you don't want to change, you have to put you have to put 1 under in the position of these bits so that you don't change them. Okay. For XOR, you can tell here 1 here, 1 means set. Okay. 0 means no change, right? Here 1 was no change here, but 0 here is no change, right? Here no change is 0. 0 is no change, like this one, right? 1 means flip. Okay, guys. Any question? Here I give 1 example for 1 bit, but you can use it for more than 1 bit. Same idea, right? So, for example, if I wanna clear 3 bits, very easy. Just put 0 0 0 here, 3 zeros, and then 1 1 1. Very easy. The bits you wanna clear, put zeros under these bits or in the positions of these bits, and the bits you don't want to change, just put ones. Any question, guys? Great. So this is what we call bit manipulation. Okay. We can also use the logic operation to do something else, to check if some bits are zeros or ones, right? Remember, we did something like this before. You remember when I explained branch if clear, branch if set? Yes, I did, right? I told you here, this instruction, I have to give a byte to this instruction, and this instruction should branch, okay, of some bits of interest are clear. So I have to put a mask, if you remember the word mask. So I have to put mask here in order to tell which bits I have to check, right? So this one is gonna branch of the bits of interest are clear. Okay, for sure you can decide these bits, you can determine these bits. Also this one is going to branch if the bits you mark or the bits you select are set. Okay, I told you the problem in these two instructions, they are short. Okay, now you can also use logic operation to do the same thing like branch if clear, branch if set. Okay, using logic operation, but this time you can do long branches as you will see right now. Actually, to be more accurate, we are going to use and, not all of them, only and. Okay, here to set, use or and XOR, but here to check we are going to use and all the time, right? Also, I want to repeat what I said before. How can you why, and that's what we're going to do in next chapter in a lot. How or sorry, why sometimes if you have a byte, why sometimes you need to check some bits? Why you? The reason is here. This we have some input. We have some pins here. This pin is connected, for example, to a switch or a sensor or a device, whatever. Okay, so that when this device puts 0 volt here, the hardware is gonna put in this bit, okay, logic 0. You don't need to do anything about this. This is done automatically, hardware, okay? And if you put 5 volt here, this 5 volt, the hardware is gonna put here logic 1, right? So again, we don't have an instruction to look at bits. So still you have to work on a byte. So I have a byte and I wanna know if the switch is open or closed. Okay. I wanna know if there is a 0 volt here or 5 volt. It may be a sensor here, right? Anyway, there should be 0 volt or 5 volt. It can be come from anywhere. It can come from a switch, it can come from a sensor, from wherever. Okay, so I need to know if there is 0 volt here or 5 volt, because if it is 0 volt, I have to do something. If it is 5 volt, I have to do something else, as you will see in next chapter. Any question, guys? So now I'm going to explain. I already somehow explained this one. How can you use the logic operation to set, to clear, to flip? For sure, I'm going to give you examples. Don't worry, I didn't finish yet, but I give you the main idea. Now I'm going to explain this one in more details. Okay, or how can you do it? Any question, guys? Okay, great. So now, yeah, this is, I'm just repeat what I said. So here, guys, I have, for example, a byte, okay? And in this byte, I want to clear this bit. I don't want to change the other bits. So as I told you, I can put here under the bit or bits, under the bit or bits I want to clear, I'm going to put 0, and then the bits I don't want to change, I'm going to put 1s, and then you can do AND operation. You got what I'm saying? So these bits are going to come no change, and then I'm going to get 0 here, right? So this is for sure. If I put 0, 0, 0, 0 and do AND, so actually if you do that, you actually clear all of them. So the result is going to be 0, 0, 0. So this will be similar to clear A. If you clear register A, we put 0 everywhere. Yes. Anyway, I'm just explaining. You may not need to do that. I'm just explaining that you can put more than 1 0. I just here example for 1 0. Here example if you put all of them zeros, whatever you want to do. Okay, guys. Any questions? Nothing is new here, but maybe in explain it in example. Same thing here, guys. How can you set some bits? Very easy. Number 1, set means you have to use OR. Very easy, right? Number 1. Number 2, the bit you want to set, you have to put 1. The bits you don't want to change, you have to put zeros. Okay, as you see here, right? If you put here 1, I'm gonna get 1. If you put 0, so I'm gonna get the same bits here again. Okay, guys, easy. If you want to flip some bits, 1 or more, okay. Again, guys, please don't be confused. Here in this example, I just give example on 1 bit, but you can use it on more than 1 bit for sure, right? So in the same instruction, so if you want to set 2 bits, you don't need to use 2 OR, right? So 1 OR, and then you can put 1 1. Okay. Next one here, you can flip some bits. Okay. How can you do that? The bit you want to flip, you can put 1 under this bit, and you can the bits you don't want to change, you put zeros, as you see here. So if you do that, zeros no change. So I'm gonna get this one here. If you put 1, if this is bit number 7, I'm gonna get bit number 7 prime flip. Okay, guys. Any question, guys? Great. Now let's come to this is what we call bit manipulation. I told you bit manipulation. How can you do set, clear, and flip? Now I'm gonna explain how can we use AND logic AND to check some bits, right? If they are zeros or ones and so on. So they are here. Look at the idea. Look here, guys. I have a byte here and I want to check this bit. Okay, I want to check this bit. So what I'm gonna do is the bit I want to check, I'm gonna put 1, and then I'm gonna put zeros everywhere. Is that okay? So what is the result? Because here there are 0, 0, and anything is 0. So actually, and then 1, and this bit, I'm gonna get this bit. Can you see it? So you know what I did? I mask it. They call it mask it. So I masked these bits by putting 0. And this bit, I'm gonna take it as is here. And now I'm gonna check this byte. I have a byte, right? This byte, if this byte is equal to 0, what means? If this byte is 0, it means this bit is 0, right? Yes, it means bit 7 is 0. So after you do AND, you can use branch if equal. So if the result is equal to 0, that means the bit or the bits I checked are zeros, right? Otherwise, if there is 1 here, the result is not 0, right? And because AND operation is going to change the 0 flag, so you don't need to use compare. Okay, so after AND, you can use branch if not equal. Again, not equal means bit number 7 is equal to 1. It was 1, right? Branch if equal means the bit I was checking here is equal to 0. Okay, guys? So let me here, I summarize what I said. Again, if, and this one is updating the 0 flag. So this is a good thing. That means you don't need to use compare, right? So again, the idea is, number 1, the bits I don't want to check. The bit I don't want to check, I have to put zeros in these bits to mask them. I'm gonna mask these bits, okay? Number 2, I have to put 1 in the bits you want to check. I have to put 1 in the bits I want to check, okay? And then if the result is 0, in other words, if the 0 flag is 1, so after you do this AND operation, your friend is the 0 flag. So go and ask the 0 flag. If the 0 flag tells you I am 1, that means the bits you checked are all of them are zeros, right? Otherwise, they are not zeros. For sure, if you check 1 bit, that means it is 1, right? But if it is more than 1 bit, if you check more than 1 bit, it means for sure these 2 bits are not zeros. For example, it can be 1 0, okay, 0 1 1 1. Okay, it can be any other case, because here I check if some bits are zeros or not. Okay, guys, I'm gonna give you some example to better understand it. But again, you see what I did here, guys. I know some students are confused in this part, okay, but you can you need to learn it somehow. Okay, so what confuses students is, listen to me, guys. If you want to clear some bits, you have to put 0 where you want to clear and put ones, right? So 0 and ones this way. But here, if you want to set, you put 1 and 0, it's no change. So this is sometimes confusing students, but you need to learn it, okay? Also, if you want to flip some bits, you have 1 and then you have to put zeros, right? You have to learn it. If you want to check some bits, the bits you want to check, you put 1, and the bits you don't want to check, you put zeros. Okay? Any question? Great. So now, any question? Because I finished a very important part. What I'm gonna do right now, guys, I'm gonna explain what instructions we have, okay? And then I'm gonna give you some examples to understand better how can we do bit manipulation, and also how can we check some bits, okay? Hopefully you understand. And even if you don't fully understand it now, you will understand it in next chapter. Okay, what I mean here, here I'm talking about how can we use this. Okay, so because next chapter we're gonna use these two here to check if the switches are open or closed, and we're gonna use this one to change the status of an LED, turn LED on, turn LED off. So you can use this one as you will see in next chapter. Okay, guys. Any question before I proceed? Okay. So let's see the instructions we have. Let's start with the AND. Okay, so we have here and A. This is one word, and A, and then you can put here memory or immediate value. So what this one is doing is here register A should equal register A and bitwise and a memory, a byte in the memory or immediate value. So I can put here a memory or immediate value. For sure, here you can use any format for the memory, as I explained before. So, and this is for a byte and byte. Okay, guys. Same thing, you can do and B this way. So same thing, but this is for register B. Okay. Also, you can do and C, CC, flag register. So CCR should equal CCR and memory or immediate value. Okay. So these three operation are 4 bytes. Okay, guys. For O, we have, that's all what we have. So we don't have AND operation for words, but still you can do it easily, right? So if you have register D, I can do AND for A and for B, right? So if I can do AND A and B, if I can use these two instructions, so this means I can do 16-bit AND with register G, right? But we don't have one instruction for logic AND. Okay, guys. That's all what we have for AND. For OR, we have similar instruction here for OR. For OR, similar, right? But here, or A, or B, or A, A here means accumulator. Accumulator means a register. So anyway, so here, or accumulator A or register A, or B, and or CC. CC is a flag register. Okay, guys. So this here are similar to these ones, but here instead of AND, it is OR. So, okay. Now for XOR, similar to these two instructions, we have XOR A, we have XOR B, but we don't have XOR CC. So we don't have this one. Okay. Okay. Any question, guys? So these are all the instructions we have. These are the instructions we are gonna use. So what I'm gonna do right now, I'm gonna give you. I'm going to give you examples to better understand what I taught before. So we are going to have examples here to better understand how can we use the logic operation and also practice on assembly language as well. Okay, so let's have a lot of examples here. Let's go through them. So let's see the first example here, guys. I'm asking you, I want to clear the upper 4 bits on in this byte, 56. So I have a byte in this memory location 56. I want to clear the upper 4 bits, and I don't want to change the other 4 bits, the lower or the less significant 4 bits. Okay, as I said before, once I tell you I want to clear, don't think about it. Clear means end, so I have to use end operation. Okay, guys. Number 2, if you go back as I explained, if you want to clear some bits, the bits you want to clear, you have to put zeros, right? The bits you don't want to clear, you have to put ones. So this is the operation I want to do, right? So the byte at the memory location 56, I want to end it with this number, and then the result, I want to store it in 56. Okay, guys? So how I can do that? Okay, number 1, do you have AND instruction? Do AND byte in a memory with immediate value? The answer is no, we don't. That's all what we have, right? So similar to what we did before, I have to load. Okay, we did it a lot. We do it a lot. If you cannot do the operation directly in a memory location, you have to load to a register and then do the operation and then return it back. That's exactly what I'm gonna do. So look here, guys. So number 1, I'm gonna load. So I'm gonna read the byte, put it in A, and then I'm gonna do the operation on A, right? As AND this way. So the result is going to be stored in A, and then I'm going to return the result back to memory. Okay, guys. Again, you can write, for sure you have, because this is immediate value, you have to put here hashtag, okay? And you can put this number in binary, that's why I put here %, okay? Or if you like a hexadecimal, you can put 0f this way, okay? But I want to tell you advice. To me, both are the same, but you have to be careful, please, guys. I remember in one lab, I spent too much time looking. one student had a problem. He told me, come and check. I checked the program, everything looks okay. Okay. And everything is okay. And at the end, I figured it out. You know what was the problem? The problem was he missed 1-0 here. Okay, he missed 1-0 here. So what I want to say here, guys, I'm okay if you use binary number, but you have to make sure in binary number sometimes you cannot catch it, or sometimes hard to see, but you have to make sure you put eight numbers here. Okay, that's why maybe using hexadecimal is easier, but both are okay, but you have to be careful here. Okay, guys, so you can do it this way. Okay, the good thing is I can use AND to do that. Okay, but also we have another instruction, we call it bit clear. We have another instruction, we call it bit clear. Okay, how this instruction work? Bit clear, and then I have to put the address here, which byte, which memory address. Okay, and then you have to put here what we call a mask. In this mask, forget it's here I have to put 0 because the AND operation work is this way, 0 and anything give you 0. No, this is completely different. Here I'm not doing AND operation. This is just a mask. You need to tell me which bits you want to clear. Is that okay? So you have to mark. So the bits you want to clear, you have to put 1. You don't want to clear to put 0. Don't be confused, please. Here, different from here. Here I do AND operation. Okay? That is why the bit I want to clear, I have to put 0. So that 0 and the bit give you 0, right? Here I'm not doing AND operation. Here, this instruction is going to clear. It's called bit clear. And then you have to give memory location here. And then you have to mark. How I can mark the bits I want to clear? Just to put ones in these bits. So if you put 1, 1, 1, 0, 0, 0, that means you are telling me I want to clear these bits, and then he will take care of it. Okay, so the good thing about this instruction, guys, is this instruction just short. Instead of using 1, 2, 3, you can just use one instruction. I like it, just short, one instruction. However, this instruction can only work on memory locations, right? So you cannot use it for a register. Okay, that's why I give you this option. Also, I give you this option. You have to learn both anyway, because when I teach C language in chapter 3, we're gonna use something like that in C language to manipulate bits. So still you need to learn this one as well. But if I have the choice to select, I'm gonna select this one because this one just easier. Wallahi. Okay. Again, how it works, guys. Let me. I think I have a slide here to. Yeah. Look. This is how it works. We have actually 2 of them. One is called bit clear. The other one is called bit set. Okay. And here you have to put a memory address for a byte, memory address. And then you have to put here a mask. In this mask, you have to mark the bits you want to set or the bits you want to clear. Okay. So here you have to put 1 in the bits you want to clear or set. You got what I'm saying? So don't think about it's completely different from in case of AND, I have to put 0 because 0 and anything give you 0, right? This is just to mark. You have to mark. So that's why if you want to clear, if you want to set, we use the same rule. If you want the bits you want to manipulate, put 1 in these bits because this is gonna you mark, right? So let's have another example here, guys. Any question in this example before I give you more examples? Okay. So let's do this one. I want to set bit 7 in byte at memory location number 10. Okay. So memory location number 10, I want to set bit number 7, and don't change the other bits. Okay. So number 1, once you see the word set, you should understand I have to do OR operation, right? We agree on that. Number 2, in order to set, as I explained before, you have to put 1 in the location of the bit you want to change. You have to put 0 everywhere. So I want to do something like that, guys. I have a byte in the memory. I want to OR it with this number, and then the result I have to store it in this memory location. Okay. Again, do you have instruction that can do a OR operation memory to immediate value? No, we don't, right? That is why, similar to what I did in this example, number one, I have to load. So memory location number 10, I'm gonna load it in register A, as you see here. Number two, I'm gonna work on register A, as you see here. And again, you can put this value in binary, but please count the number of zeros, because if you forget 10, you know what's gonna happen if you forget 10? This will be bit number 6, not bit number 7. You got the problem? Yeah. And this is what exactly happened in, I told you in, before in one lab, right? So very tricky, because sometimes because you have many zeros, sometimes your eyes cannot catch it. So you try to think, especially if the program is long. So anyway, that's why maybe hexadecimal usually better. But if you want to use binary, I'm okay. But you have to be careful to avoid making mistakes. Okay, guys. So here, this is the number I'm gonna put here, and then after that, I'm gonna return the value back to number 10. So load or store. Okay, guys. Any question? Okay. So this is one idea to do it. We have another idea. I told you we have one instruction. It's called bit set. Very easy, right? Bit set. This one is similar to this one, right? The only difference is this one is gonna clear, this one is gonna set. But everything else is the same. So here you have to put a memory location here. So you have to put here a memory location number 10, and then you have to put a mask here. In the mask here, okay, you should not put hashtag here, because there is no confusion. This is always a number. It cannot be a memory location, right? So anyway, so so here you have to mark the bit you want to set, because I wanna set the bit number 7 here. So I'm gonna mark this one. I'm gonna put 1 here and 0 everywhere. Okay, guys. Any questions? So this one is similar to these 3 instructions, but this one is easier for sure. Okay. So if I use, instead of bit set, I use bit clear. So this bit number 7, I'm gonna clear it. If I use bit set, so this bit I'm gonna set it. Any question, guys? You understand it, guys? I will see in the quizzes and exams if you do well or not, but don't be shy. If you have any question, just unmute, talk to me. Okay. Okay. So now, again, I'm going to give you another example about how can you flip some bits. Okay. So here I'm asking you flip bit number 7 in the byte at memory location 10, and for sure don't change the other bits. So the way I'm going to do it, as you see here, guys, because flip means XOR, so I have to XOR. And you know, in case of XOR, the bit you want to flip, you put 1, and the bits you don't want to flip, you put zeros. Okay. So here, because 0 means no change. So if you put 0 here, these bits are going to come here, no change. And this bit is going to flip. So I want to do something like that. So here, do you have an XOR instruction to do XOR for a byte in memory and this immediate value, and to store the result in this one? No, we don't. So we don't have the instructions that can work on XOR instruction that can work on memory directly. So number one, as you see here, guys, I have to load. So I have to read a byte from memory, put it in A, right? And then I'm gonna work on A, as you see here. Okay. So now I did the XOR, but the result is in A. So I have to return it back to memory. Okay, guys. Any questions? So here I'm giving you a summary. Look here, guys. If you want to set some bits, you have to use or you can use bit set or bit clear. Sorry, bit set here. If you want to clear some bits, you can use AND, or you have to use bit clear. Okay, but I like bit set and bit clear because they are short. But keep in mind, these only work for memory locations, so they cannot work for a register. So if you want to work on a register, you don't have option other than these two. Okay, or if you want to flip some bits, you can use XOR as I explained here. However, we don't have bit XOR, so we don't have something like that for XOR. Okay, guys, any questions? Okay. So as I told you, tomorrow we're gonna have a quiz on branch and loop instructions. Okay. Yeah, I think that's what I explained. Bit set, bit clear. Okay. Okay. Also, yeah, for bit set, guys, as I told you in bit set, you can put here a memory. So you can put any format of the memory, right? So you can put immediate, sorry, you can put direct memory format, or you can put something like that, indexed, something like that. So you can do any format of memory. For sure, this is useful if you wanna, if you have X, as I said before, X can be used as a pointer in memory. So this can be one element in an array, right? So here I'm gonna set bit number 7 in a memory in the array, right? Okay. Anyway, another thing I don't want I want you to remember, we have two set of instructions that they are very close to each other, writing, but they are completely different as an instruction. So if you look here, guys, we have B set, bit set. So this one is going to set a bit in a byte. Bit clear. This one is going to set some bits in, sorry, it's going to clear some bits in a byte. This is completely, if you add letter R here, it's completely different. Now it became branch if set, branch if clear. And I explained these two before, right? So I just want to tell you here, this is completely different from this one. This one, it check. Here, you check. You branch if some bits are set or clear. Here, you don't manipulate the bits. Here, you manipulate bits. Okay? Here, you only check. Regarding the format, this one is the format is different. Here, you say branch if set. You put a memory location like this one. You put a mask like this one, but this one has a label. This for sure, this one doesn't have a label because this is not a branch instruction. Okay, guys, I just want to pay your attention to this because these two instructions are very close. Only one letter difference in one letter. In the writing is very, or spelling is very close, but as an instruction they are completely different. These are bit manipulation. These are check. This should check some bits and the branch if some bits are zeros or ones. Okay, guys. Now what I'm gonna do, I told you before, all this topic is about how can we use logic operation to manipulate bit, and I think I explained it very well. I give you a lot of examples. Now you should know, if you have a byte, how can you set some bits, how can you clear some bits, how can you flip some bits. Okay, that's easy. Now I'm gonna move to the next part here. I'm gonna give you example. If you have a byte and I wanna check if some bits are ones or zeros, so that I can make some decision. If the switch is open, I have to do something. If the switch is closed, I have to do something else. You know what I'm saying? So to do that, I told you before, we can use branch of clear or branch of set, or you can use some logic operation to be more specific, and operation. So now I'm going to give you example of this right now. Okay? Yes. So now I'm telling you here, guys, look, branch to next. So go to somewhere. I'm gonna call it next, any name. Branch to next. If bit number 0 of the byte at memory location 10 is 0. Okay. So if this bit is 0, go to this location. Okay. Let's start with the easy one first. So look here, guys. I can do something like that. Branch if clear. Branch if clear. And then here number 10, a byte in the memory, right? Again, this one also work on a byte in the memory. It cannot work on a register or on on a register. Also, only it has to be a memory here. Okay. Also, this one is short. This branch is short. Okay. So, but this one can be long. This one can work on a register. Also, it can work on memory as well. Right. So here, branch if clear. Here I put the address, which memory location, and then this is the mask. This is my mask. It's 1 0 0 0 0 0. Again, you don't need to put it in hex in binary, guys. You can just put number 1 in hexa. You can convert to hexadecimal. Anyway, so here I'm saying, please check bit number 0. That's why I mark 1 here in this byte, in this memory location, and if it is set, go to next. Right? This is how it is. Okay. So now how I can do the same thing like this one, but using AND operation. I told you before the way I'm going to do it. Look here, guys. This is the byte at the memory location number 10, I want to check this bit. I want to check this bit. So to do that, I'm going to put 1 here, and then I'm going to put 0 everywhere. So I'm going to mask these ones because I don't care about you. I don't care about you. I just care about this one, right? So the result should be 0, 0, 0, 0, and be 0. So whatever here is going to come here. And now if this result is 0, and it's going to set the 0 flag. If not, so it's gonna clear the 0 flag, and then after that I can use branch of equal or branch of not equal. So let's see how I can do something exactly like this one here. Okay, number one, because I don't have instruction to do AND operation between immediate value and memory location, right? So I have to do it through a register. So now I'm gonna read the byte. I'm gonna put it in register A, guys. And then I'm going to do AND A with this number here, right? With this number here. And you have to put here hashtag, right? Otherwise, if you don't put hashtag, this one will be taken as a memory location, okay? So here you put hashtag. So I want to check this bit here. And now, if it is equal to 0, you don't need to use compare here. You don't need to use compare. Because if the result is 0, AND is going to set the 0 flag. And this guy just needs the 0 flag, right? So the 0 flag is going to be set by this instruction. Okay, so very easy. So all what you have to do, put 1 here and zeros if you want to check this bit, guys. And then if the result is equal, what it means? If the result is equal to 0, what it means? Because I already forced it. See, look at the logic, guys. Understand the logic. I force these bits to be 0. I force them, right? And now, if the whole result is 0, that means this bit is 0, right? Otherwise, if the whole result is not 0, that means this bit is 1, right? So here I'm going to say if the result is 0, please go to next. Is that clear, guys? I'm explaining it here. If A should equal 0 or 1, right? So if A is equal to 0, that means bit 0 is 0, bit 0 is equal to 1, and in this case the 0 flag is 1. Here the 0 flag is 0, and then I can use branch of equal or branch of not equal to check the 0 flag and jump to see what you want to do after that. Okay, so if you want to check, I want to check bit 0. If it is 0, so I'm going to go to next, and then I'm going to write 0, whatever you want to do. Okay, any question, guys? Okay, let me tell you something important here, guys. You remember what is the difference between compare instruction and subtraction, right? I told you before, both of them are going to do subtraction, and both of them are going to update the flags. However, in case of subtraction, I'm interested in the result. So I want to get the difference so that I can use it in computation, right? But for compare, the result is not stored anywhere because I'm not using compare to get the result. I'm using compare to set the flags. Okay, it's the same idea here, guys. Okay, what's going to happen here? This instruction is going to destroy the value of A. If this is okay, it's not a problem. Okay, you can use it. That's okay. If it's not a problem, right? But if the value of A, you want to use it later somewhere, and you don't want to lose the value of A, because the result here, this one is going to do AND operation, and the result is going to be stored in A. So this one is going to destroy A, right? So this instruction, actually, guys, number 1 is going to do logic AND. Number 2, update the flags. Number 3, store the result in A, right? If this is okay for you to destroy A and then you can get it later, that's okay. Okay. Otherwise, we have another instruction. We call it bit A. Okay. What is the bit A? And then I put here the number, this number here. So instead of AND, I use bit A. So what is the difference between this one and this one? They are exactly the same. There is only one difference. The difference is here the result of the AND is stored in register A. Here the result is not stored anywhere. So this one similar to compare, right? But for AND, compare for subtraction. Is that okay? So what this one is gonna do? This one is gonna do AND operation, number 1. Number 2, update the flags, right? That's it. That's it. And then the result is not gonna be stored in A. So this one is not gonna change A, but this one is gonna change A. Anyway, again, if this is okay for you, you don't care if you destroy him. Okay, that's okay. No big difference between them. Right? Any question, guys? Okay. So we actually have two of them. So we have bit A and also we have bit B. So only we have two of them here. So we have bit A, memory. You can put here memory or immediate value. You can. So this one is gonna do AND and update the flags. The result is not stored anywhere. For this one, the result is stored as I told you before. So this is the only difference between this one and this one, right? We have also bit B. So we have bit A for register A. We have bit B for register B. Now I have some very interesting examples here. I'm gonna just to more understand this topic, because this topic is really very important. So I'm gonna give you more examples here. Again, by the end of this topic, guys, please make sure you understand. Okay, if you have a byte, how can you check some bits in this byte to know if they are 0 or 1, right? We will need it, right? Later in chapter 3. This is one thing. The other thing is, if you have a byte, how can you manipulate some bits in this byte and don't change the other bits? And manipulate here means, how can you set, how can you clear, how can you flip some bits? And we are going to need it next chapter again. Okay, guys? If very important, that's what we are going to need. We use it a lot. Okay. So let's see some more example to better understand it, guys. So here I want to branch to a location. I call it next. Can be any name. If either P0 or P1 in memory location 10 is 1, right? Again, I said it before, but just the first bit here, I'm going to call it bit 0 all the time. So all of the time, I'm going to start just in exams, in final, or in anything. When I say bit 0, I mean the first one and last one, bit 7, right? So if either bit 0 or bit 1 in memory location 10 is 1, right? So that means if either, the word either here means if any one of them is 1, right? So I want to go to next. So let's look here, guys. What all the possible values for these two bits? It can be 0, 0, it can be 1, 0, 0, 1, 1, 1, right? This is all the possible values, right? So here I'm saying either. Either means any one of these, right? So it means at least one of them is 1, right? So if these two bits are 1, 0 or 0, 1 or 1, 1, so in this case I have to branch to next. That's exactly what I want you to do here. Okay, guys? Again, this is important. Listen to me. Here, I can check if some bits are zeros. All of them are zeros, right? But I cannot check if one is 0 and one of 0 and the one of 1, unless you do it in 2 instruction, right? But it's not in 1 instruction. Okay. Anyway, so let's see how I did it, guys. So what I'm gonna do, I'm gonna check these two bits. So I'm gonna put 1, 1 and 0 everywhere, right? And now, if the result, if branch if equal, if the result is 0, what it means? It means these two bits are zeros, right? So I'm gonna put 1, 1 and 0 everywhere. Because I put 0 everywhere, so forget this part. This part will be 0, right? And here I'm gonna get the byte I'm gonna get is bit 0, bit 1, and then I'm gonna get 0, 0, 0, 0 to the end, right? So here, if I get 0, that means the two bits here are zeros. If it is not equal, right, that means so the result is not 0, which can be 1, 0, it can be 0, 1, it can be 1, 1, it can be any of these one. Okay, so let's see how I did it here, guys. Again, I'm gonna take number 10 here. I'm gonna do AND operation between register A and this number 1, 1, 0, 0, 0, 0, and then I'm gonna say branch if not equal to 0. So if this one is not equal to 0, you have to go to next, right? If it is equal to 0, so I'm gonna come here. I'm gonna come here, right? So if the two bits are zeros, I'm gonna come here. If anything else like 1, 0, 0, 1, 1, 1, I'm gonna come here. Okay, guys. So it's like I have two groups. I have two groups. One group for all zeros, one group for any other option, right? So or any other combination. If all zeros, I'm gonna come here. Anything else, I'm gonna jump between. Okay, guys. Is that clear? Any questions? Please ask me questions. Please try to find any question and ask me. Okay. So yeah. So same thing, guys. If you use branch if clear, branch if clear again is gonna branch if all are clear, right? It's not gonna branch for any other thing like 1 0 0 1 1 1, right? Branch if set, this one is gonna branch if all bits, okay, you are interested in are ones. Otherwise, so this one is gonna is not gonna branch, right? So if it is anything else. Yeah. Now I want to give you another example. Here, look here, guys. Now I want to branch if bit 0, bit 1 are equal this exact number 0 1 0 1. So that means this one has to be 0 and this one has to be 1, right? In location number 10, right? This is different from what I explained before or what we did before. What I did before, listen to me, this is confusing a little bit. Okay, so let me explain it. What I did before, I'm going to check some bits. I'm going to branch if all of them are zeros or all of them are ones. That's what I have, right? Now I'm asking you if it is 0 1 0 1. Okay, so that means I cannot do it using one instruction, so I'm going to do it using two instructions. I'm going to check this bit first, right? And then I'm going to check this one. So let's see how I did it. So now I'm going to say branch if set. So okay, so I'm going to check the first bit here. Okay, I'm going to say branch if set. If this bit is 1, if set is 1, so go outside. It's not 1 0, right? So I'm gonna, it's like two conditions. I'm gonna check the first condition first. I'm gonna check one by one, right? Because why again, guys, listen to me. Why I need two instructions? Because they are different numbers. You know, if it is 0 0, I would use one instruction. If it is 1 1, I would use one instruction, right? But because they are different, that's why I have to use two different instructions. So let's see how I did it. So here I'm gonna check the first bit here. If it is set means it is 1. So that means, so I'm done, right? Because that means it's wrong. It means bit 0 is 1. So the first condition. So I don't need to check the second condition. I'm done, right? So go outside, right? But if the first one is 0, this branch is not going to be taken, and I'm going to come this way. So if bit 0 is equal to 0, I'm going to come this way. So the first condition is true. Now I'm gonna check the second condition, right? I'm going to say here again, I'm going to say branch if it is clear. So if the second one is false, I'm going to go outside, right? If I come to here, what it means? It means bit 0 is 1, bit 1 is 0. Okay, why? Because it means this branch has not been taken and this branch has not been taken. That means this branch should be taken if it is 1. If this one should be taken, I think I made a mistake. I'm sorry. Yeah, I think this is 0, 0 is 1. I'm sorry. Right? Yeah, bit 0, bit 1. I'm sorry. So this is 0 and 0 is 1. Okay. So that means these two branches have not been taken because this one should be taken if the first bit is 1, right? So if this one is not taken, means the first bit is 0, right? And this one has not been taken, right? If this one is gonna branch is taken if it is 0. If it is not taken, it means it is 1. Okay, guys, is that clear, guys? Again, it's a tricky point here. You should understand what I explained before. You can check if all or some bits or all of them are zeros or all of them are ones, right? Here I give you. I want to look for this number 0 1. That's why I need two conditions, right? Any question, guys? Okay, great. Now I have also a very interesting example. Maybe let me show you. I have also a nice picture here. Okay. Okay. So here, what I'm explaining, I have a car. You have a car, nice car. Okay, Tesla car. So you have a very nice car here. Okay, guys. And then in this car, I'm gonna read a byte this way at the location 0 0 0. Okay, and this byte, every bit here, some bits, yeah, for example, bit number 6 is gonna tell me if the left door is open or closed, right? Right, bit number 5 tells me if the right door is open or closed, right? And also I have some bits here to turn on or off the cabin light, right? So here you need to check some bits. I'm going to give you different logics here. So for example, this one logic, I want to turn the cabin light on, by putting one where I think here in this bit. This bit is connected to the light, right? If you put one, you turn the light on. If you put zero, turn the light off, right? So this bit you need to manipulate, right? These two bits you need to check to know if the door is open, left door is open or closed, and right door is open and closed. And based on the check here, you have to make a decision, either turn the light on or off. So I try here. So it's just one byte. Some bits you need to check, some bits you need to change to manipulate by using different logic. So let me explain it to you how it works. Very interesting. So here, okay. Okay, guys. Oops. Okay, look, guys, this is a byte at memory location 1000. I told you these two bits I can check. This bit number 6 here, guys, is 1 if left door is open, otherwise it is 0, right? Now, bit number 5, it can tell you if the right door is open or closed. If it's 1, it means open, 0 means closed. So you need to check these two bits to know if the door is open or closed. And then based on that, you have to make a decision to turn the light on or off, right? Very easy, very interesting. So here, the light is one bit here, okay? 0 means you turn it off. Sorry, 0 is on, 1 is off, I guess. Anyway, that's not a problem. So number 1, let's here I give you different logics. Okay, let's see the first logic. I want to turn the light on if the two doors are open. Okay, so that open here means 1 1. So if this is 1 and this is 1, I have to turn. So if this is, as you see here, guys, if it is 1 1, so I have to put 1 here to turn it on. I'm sorry, here I think this is a mistake. The on, 1 for on and 0 for off, right? That's okay. Sometimes we do the opposite, but it depends on how you do the hardware circuit. So anyway, so 1 here means on, 0 means off. Okay, so all what I have to do, guys, I have to check these two bits. That's what I did. So I'm going to say branch if set, if both of them are set, right? And this is the memory, this is the address. And then here I put 1 1 here because I want to check bit number 5 and bit number 6 here, right? So if these two bits are set, 1 and 1, that means the two doors are open, right? And based on this logic here, I have to turn the light on. So if it is 1 1, I'm gonna come this way. Anything else like 1 0 0 1 1 1 is gonna come. I'm sorry, 0. This is 0 0. Should come this way, right? Anything else 1 1 has to be this way, okay? Because this is branch if set. So I'm gonna come here, guys. Once I come here, what should I do? So I have to turn the light on. So bit set. So I have to do bit set to turn the light on by setting by storing 1 in this bit. Is that okay? Okay. What if I come here? If I come here, what should I do? Now I have to turn the light off because the two doors are not open. So I'm gonna use bit clear, and then I'm gonna put here 1 so that you can turn the light off. Okay. So if the two doors are open, I'm gonna come here. Otherwise, anything else, I'm gonna come here to turn the light off using bit clear to manipulate this bit here. And then after that, don't forget this one, guys. I know I told this many times. This is a common mistake. If you forget this one, okay, no matter what, you are gonna turn the light on, right? Because all the time you are gonna go the way. If you jump, you will come here. If you go this way, you are gonna come here as well. So you need to skip this one using branch next. Okay, guys. Any questions? Have any question? Let me know. Okay, guys. Let me see. Okay, guys. Any questions? Okay. Let's have another logic. Let's see this logic. I want to turn the cabin light on, right? If either door is open, right? Either door is open. Either door is open means 1 0, right? 1 0 means this one is open, or 0 1 means this one is open. Now it means these two doors are open. I think this is the logic we use in our life, right? So in our cars, if either door is open, the light is on usually. Okay, so this is logic we use. Okay, anyway, so here So if the two bits are 1 0 0 1 1 1, so I have to turn the light on. Otherwise, if the two bits are zeros, we have to turn the light off, right? So I'm gonna program it this way, as you see here, guys. What I'm gonna do. So this is an important point, guys. Listen to me. I'm gonna repeat it again. The instruction I taught before, it can look for this case. It can look if all the bits are zeros, all the bits are ones, right? So here I'm gonna branch in case of this one. So I have to look at this one, right? So that's what I did. So I'm gonna say branch if clear, and these two bits. So if these two bits are clear, so I have to go to somewhere to turn the light off. I have to come here, and then I have to turn the light off. To turn the light off, again, bit clear, and I have to come to the first bit to, sorry, the second bit, 0 1. So the second bit I have to clear it to turn the light off, right? Any other case here, okay? So this branch is gonna be taken if these two bits are clear. Otherwise, I'm gonna come this way, right? When you come to this way, I'm gonna turn the light on, right? And then again, you have to skip this one. Don't forget this one. You have to skip this one, right? That's why I'm stressing too much and repeating why about case like this one, because it's very dangerous. Why it's very dangerous? Because code order is not going to give you error, right? You will run your program is going to run, but it's not correct. You got what I'm saying? So it's logical error. So it's very, you may waste too much time looking for this error. Anyway, any question, guys? Okay, I think I have one more logic. So in this logic, I'm telling you, turn the cabin light off if both doors are closed. Okay, so if the two doors are closed, so here, I think maybe this one is closed somehow. Oh, yeah, I think it's very close to this one. How it's different. So here, I'm gonna branch if clear. So if these two bits are clear, right, 0 0. So I'm gonna branch to here so that you turn the light off. Okay. If not, I think yes, a small difference. So this one is similar to this one, but the only difference here, I want you. Oh no, sorry, yeah. I want to turn the light off if both are zeros. Otherwise, turn it on. But here, I'm not saying that. Here I'm saying if both, I'm not asking you to turn anything on. I'm saying if both of them are closed, turn it off. That's it. So that's what I did. So here I'm gonna check these two bits, right? If they are 0 0, that means I have to come here to turn it off, right? Otherwise, do nothing. So that's why I didn't turn it on here. Do nothing. So I skip. Anyway, it's very close to the previous logic. Any question, guys? Okay. Now I'm gonna move to, so let me summarize what I did, guys. So number one, okay, let me go here because I want you, because we're very close to finish this chapter. So we're gonna have the first test is gonna be on chapter 1 and chapter 2, and it's gonna be during Friday. During the lab session after the March break. Okay. So anyway. So let's see what I did so far, guys. I explained data transfer instruction, load, store, equal, right? How can you make equal in assembly? I explained arithmetic instruction. We did a lab on this one. How can you add, subtract, multiplication, division, increment, decrement, and so on, okay? Also, I explained how can you do branch and loop instruction, right? I explained how can you do for loops, while loops, okay, using assembly. Also, how can you do the statements you used to do in C language, like if statement, if else, else if, and so on. Okay? And then I explained how shift, rotate instruction. And next week lab is going to be about shift and rotate instruction, and Boolean instruction as well. And also explained how can you do bit test, or how can you check some bit, how can you manipulate some bits. Okay. Now only two sections. The last one is just very easy, so it's only two sections are left. One of them is about stack. So I'm going to explain what is a stack, what instruction we use with stack, and so on. After that, I'm going to explain subroutines. functions or subroutines. Okay, how can you do subroutines in assembly and how they work? So let's start with stack. Okay. Any question before we move forward, guys? Okay. So what is stack? Stack very important, by the way. So all the programming language use stack, right? So your computer, your phone, any program, there should be a stack. Otherwise, it doesn't work. I'm going to tell you what is a stack and how we use it, right? So here, number one, stack is not a new device. It's just a part of memory. So you have my memory. I'm going to take a part of the memory. I'm going to reserve it for a special purpose for a stack, right? So stack is just a part of memory. I'm going to use it as a stack. So what this means? It means the way in this part of memory, the way we're going to read or write is different from what we did before. That's it. So it means very easy, very easy. So we have our memory. I'm going to take part of the memory, right? You know what memory is doing, right? Memory is we store data in memory, right? However, the way we read or write is going to be different from what we did before. So stack is storage, right? Stack is a storage area, but you will read or write in a different way. That's it. So let me first explain how we read or write, and then for sure I'm going to elaborate. I'm going to tell you how it is useful, very useful. Okay. So number one, how can we read or write from memory? Okay, there are several ways, but one way here, that's what we did before. We call it what we did before. We call it random access. Random access means you can tell from the English name random, right? So random means there is no sequence. So I can say I can read location number 10, and after 10, I'm not forced to read 11, 12. So there is no sequence. It's random. So after 10, I can jump. I can read location number 7,000. That's why it's called random access. That's what we did. This is how we used the memory before, right? So we used the memory before, and the way we access the memory random. Random means we can write anywhere. There is no specific sequence. You can read from anywhere, right? So you can read this one or write this one anywhere, right? But stack is different. Stack is different. Stack, to read or write, we have a rule. We have a rule. What is the rule? Last data in is the first data output, right? The last data you store, the last data you write or stick the stack, should be the first data you read from stack, you get from the stack, right? So it's not random. So if you tell the stack, give me a data, the stack is going to give you the last data you stored in the stack, right? So last in, first output, right? I have a very good example here just to understand it better. Again, I'm making definition to understand what is stack. And for sure, don't worry, I'm going to explain how, okay, it looks somehow weird. So how can we use it? I'm going to explain this for sure. But let's now, yeah. So the word stack, it may come from if you have, oops, sorry. If you have a stack of plates, something like that, guys, okay? If you have a stack of plates, something like that. So if you want to take a plate, you have to take the last one you put, the last plate you put, right, is the first plate you take. So if you wanna put on this stack, you have to put on the top. This is the top, right? If you want to take, you take the one on the top. You cannot take the one in the middle, right? So you have to take them in sequence, right? So you can imagine every plate here is like data, byte or word, right? So there is something we call it the top of the stack. The top of the stack is where, if you want to write, I have to put on the top something here. If you want to take, you have to take from the top, right? It cannot be anywhere, right, guys? So here you should, again, what I'm saying is that I'm giving you a very good example here. If you have some plates this way, right? If you want to read or write, you have to read or write from a certain point, from the top here. If you want to take a plate or if you want to take a byte, so you have to take it from here, from the top, right? if you wanna write, you have to write on the top. You have to put a plate on the top, right? This one thing. The other thing you should understand is last in, first output. The last plate you put is the first one you take, right? So I have a very good example here. We can take a look at it. Assume this is the stack. So you can see the stack. All the stack is, you can see like a plates here, guys. Okay. All the time it can grow or it can shrink, right? So every time I read or every time I take plates, it's gonna shrink, right? Every time I put plates, it's gonna grow, right? So this one you can see it's gonna grow or it's gonna shrink every time you read or write, right? So you can see this one like a stack, right? So the stack here we have this plate, 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 plate. So instead of plate, we have bytes here. So this is a stack. We have 1, 2, 3, 4 bytes, right? Now I'm gonna take the stack. Stack, give me a byte. So the stack is gonna give you EF, the one that's on the top, right? The plate on the top. So you are gonna get EF, right? And then now this is your stack. And now I have a new top. You can see, guys. So before I read, the top was 1005. This is the top of the stack. So if I want to write, I have to write on this top. If I want to take, I have to take the one that's at the top, right? So, and then after I took one byte, the stack gives you this one. Now this is my stack. And now I have a new top. Now the top of the stack is 1006, right? Now I'm going to tell the stack, please stack, give me a byte. So the stack is going to give you B1, right? The one that's at the top. And now we're gonna, every time you read or write, you are gonna change the top, right? Makes sense, right? And the top here is address, is the address. So here, 1005 was the top. So the top of the stack at 1005. You should understand what I mean by top. I mean, it's like the top here. If you wanna take, you have to take from the top. If you wanna write, you have to write on the top, right? Not, you cannot put anywhere, you cannot get through because it's not random access, right? So here the top is 1005. Okay, guys. So if you tell the stack give me one plate, stack is going to give you this one, right? And now the top is going to change to 1005, as you see here, right? After that, I'm going to tell the stack give me a byte. Stack is going to give you this one, right? And now my top is 1007, right? Shrinking. Every time you read, it's shrinking, right? Now if I write here, so now I'm going to write, this is my top. So I'm gonna write on the top here, right? So, I'm gonna write. So now it's growing. So it is much like a variable length array. Yes, it's like a variable length array. Every time I write, it grows. Every time I read, it shrinks. Is that okay, guys? And always there is something we call top of the stack. So this is where you always read, or this is where you have to write on top of it, right? This is the top of the stack. So where the top of the stack is stored, where the top of the stack is stored, you remember very early when I told you we have a register, and this register is called a stack pointer. We have a register. This register is 16-bit register. We call it a stack pointer. And I told you I'm not going to talk about this register now because this is completely different from register A or B or X or Y. Because it's not general purpose register, so I'm not going to use it in calculations, in addition, subtraction, something like that. This one has a special function, so this one should point at the top of the stack. So always the stack pointer should store the address. That is why the stack pointer should be 16-bit, because stack pointer always should store the address. And every time you write something, the address should go this way. Every time you read, you go this way. By the way, write or read, usually we don't, with a stack, usually we don't use the word write or read. So I'm not going to say write or read anymore, right? So usually write, we use the word push. Push means write, but just we use this expression, push, or this term, push. If you want to read, we call it pull. So from now on, I'm going to use the word push if I mean I want to write to the stack. I'm going to use the word pull when I mean I want to read from stack. Is that okay, guys? So what happens is here, every time I write something, the stack should grow, get bigger, right? Grow, it has to grow, right? And when it grows, a stack pointer has to move to smaller addresses. So I start from big address, as you see here, 1008, and then when I added something, so I grow in the direction of, again, this is how they design this stack. Don't be confused. Maybe other microcontroller, they design it in the other way, but that's okay. It's still the same idea, same concept. But for our microcontroller, the stack is gonna grow from big address to smaller addresses, and it's gonna shrink every time you read something or you pull. The stack pointer has to go this way from big addresses to smaller addresses. Is that okay, guys? Conclusion, because it's already 4:20. Conclusion, very easy. Look here, guys. We have something, we call it a stack, right? A stack, memory. It's just memory, store data. That's okay. However, the way we're gonna store data or the way we are gonna read data is gonna be different from what we did before. What we did before, it was random access. I can read any location. I can write to any location. Now, no. If you wanna write, you have to write on top. Okay, so it has to be, if stack pointer is here, so it has to be on top. If you read, you have to read on top. So how can I know this top? Who's gonna track? Because this top is gonna change every time I write. So I have a new top. So if you write something here, my top is gonna be 1005, right? And then 1004, 1003. So every time you read or write, you change the top of the stack, right? So who's gonna track this stack pointer, right? It's very close to PC, program counter, right? Program counter should track which instruction we have to execute next. Okay, it's almost the same idea. This one should store address, but this address is not for instruction as PC, but it's still a pointer. It's a pointer. So SP is a pointer. Also PC is a pointer. Okay, I think that's enough for 21. Okay, guys. Any question, guys? Anyway, so do your best, guys, in the coming lab, it somehow needs some work. I feel it's necessary to understand how can you do branch and loops. Okay, to try to read the slides. I think the slides are very easy, and also all the lectures I posted them online, so you can, if you miss one lecture or if you don't understand one part, you can go to the lecture. You can see it again, and then we are here to help you. So if after all of that, if you need help, you are very welcome to ask us to help you. We are here to help you. Okay, guys. Anyway, any questions? Okay, thanks. Bye.